Good day again. So in this video I'll be showcasing the different research concepts that were used throughout the Bird Hunter application and how they were incorporated. So the research concepts that were used are solid principles, repository pattern, model view controller pattern, singleton pattern, factory pattern, code generation tool, source control management tools, package management tools, unit testing and test automation, continuous integration using a continuous integration server. So throughout this video, I'll be showing you how each were incorporated and giving a short description of each basically. So let's get right into it. Okay, so firstly, solid principles are basically design principles that encourage us to create more maintainable, understandable, and flexible software. And the it's actually abbreviated, so it's SOLID, S standing for single responsibility. Single responsibility basically states that one class should have one purpose. So let me show you how I um, incorporated that here. So here we have the profile model class. Basically just storing the first name, last name, email, license, password, etc. in an instance of profile. And in a separate class, we have different functions and methods to send this data to the database and read it from the database. Whilst we could have all of this in one class, the single responsibility principle says that each class should only have one purpose, so that's single responsibility right there. Okay, so secondly, we have the open close principle, which simply means classes should be open for extension but closed for modification. So here we have a root component class that is comprised of basically one function, alert message, which displays an alert message to the user based on, well, no, not based on anything, but yeah, displays an alert message to the user. So say we would want to change something. The principle says that, you know, it should be closed for modification. So what we would really like to do is, let me show you an instance where this class is used. So we want to display this alert message somewhere and change what it says. So here we go. So we can see where we extend the root component class that we're just talking about. So it's open for extension but closed for modification, and we can change what the alert message is actually saying here instead of changing it in the root component class. Okay, so we're now on part L of the solid principles, which the L stands for Liskov substitution, which basically means if a class is a subtype of class B, then we should replace B with A without disrupting the behavior of the program. But this principle was not incorporated because it didn't necessarily have to be incorporated, because we had no real subtypes of any classes within this particular application, so this wasn't incorporated in this application. And then we move on to I, which stands for interface segregation, which basically means that larger interfaces should be split into smaller ones. And again, this didn't have to be incorporated in this particular application because we didn't have large interfaces or several interfaces where we would need to incorporate this principle. So next we're on D, which is D being of the solid principles, SOLID, solid. D means dependency inversion, which basically means that high-level modules, instead of high-level modules depending on low-level modules, both will depend on abstraction. So here we have, again, back in the profile model, violation type and hunting session depending on profile model. Okay, so we're moving on to the next principle that we incorporated, which was repository pattern. A repository pattern basically is something that mediates between the, well, no, a repository pattern mediates between the domain and data mapping layers. It allows you to pull a record or number of records out of data sets and then have those records to record on work. Yeah, and then have those records to work on acting like an in-memory domain object collection, and then you can also update or delete records within those data sets. So that's basically what a repository pattern is. So we'll show you where we incorporate that here. Okay, so here we have a profile model with, just first name, last name, email, and then the implementation of the interface we just showed. It will look like this, where we can get, put, post, delete the profile like we were saying before. Yeah, like we were saying before, that the repository pattern allows us to update and delete records within those datasets. So all this function is basically doing is get, put, delete all these things from the database. So yeah, this allows us to control the profile here. So the next research concept is model view control pattern, which this pattern specifies that an application consists of a data model, presentation information, and control information. And this pattern requires that each of these be separated into different objects. So let me show you a model here. And a model contains only the pure application data. It contains no logic describing how to present the data to the user. And let me show you the view. And the view presents the model's data to the user. The view knows how to access the model's data, but it does not know what this data means or what the user can do to manipulate it. So here we have the email and password. So now we have the controller. The controller exists between the view and the model. It listens to events triggered by the view and executes the appropriate reaction to these events. So yeah, that's basically the model view control pattern summarized on how we implemented it. You can see we were showing these things before. Okay, next we'll move on to the singleton pattern, and for that we move back to Microsoft Visual Studio Code. Okay, so the singleton pattern is a design pattern that restricts the instantiation of a class to one object. There are two ways to make a service a single pattern in Angular. The first one is declare root for the value of the injectable provided in the provided in property, and the second way is to include the service in the app module or in a module that is only imported by the app module. So I could show you the second way, include the service in app module. Yeah, here we go. Yeah, we incorporated the first way, so this would be how we incorporated the singleton pattern. Okay, so now moving on to this another research concept, factory pattern. And the factory pattern is one of the creational software design patterns. This design pattern provides a generic interface to create objects. It works with a creator that produces products, so here we have where we create an object right here, where we import it from here. So yeah, that's basically the factory pattern in a nutshell. Okay, so the next research concept is code generator tool. So what this basically is it that it generates code for us. We don't have to sit and type it out. So Angular can do this by, there's a command called, I think it's ng component, which would create a component over here and then just have these classes with some already generated code. I don't think this is the right command, but let me show you in Visual Studio Code. Okay, so here we can see in Visual Studio Code, so this was auto-generated by Visual Studio Code from our database. So we had database isn't open now. So yes, as I was saying, Visual Studio auto-generated that code from our database, so we can see the same values here. And if we go back, we can see the same values here. So we connected the database with that table, and then it just made that code for us. So that is basically what code generator tools do. Next is source control management tools. These are all about the way software changes are made. It has a number of goals which are fundamentally geared towards ensuring that development teams can deliver high quality code, changing at faster speeds by improving tracking, visibility, collaboration, and control throughout the release cycle. So just to quickly touch on what they meant by tracking, visibility, and collaboration. So here we can see over here the different contributors to specific parts of code, and this code is under version control, might I add. You can see each line. You can see that I committed this. You can see the time, the day, everything, how many changes I made on that specific line. So source control management tools can protect original source files from any kind of mishap and enables all team members to look at who has made what changes at what point, as I just showed you before. And the tool we used for this was GitHub. The next research concept is package management tools, and basically a package manager or package management system is a collection of software tools that automates the process of installing, upgrading, configuring, and removing computer programs for a computer's operating system in a consistent manner. So throughout this application, you may see stuff like import routes, root modules, editor components, and all of these things that were imported. Like here we can see import this from Angular core and such. These were all imported using a package management tool. And these packages for Angular are stored in the node modules, and we would use the npm, the node commands to install stuff. So node install, npm install, whatever. But I'll show you better in Visual Studio. So here we go to tools, and you get package manager, and we can see the so that is our package manager, and we can see the different packages we have installed on this application alone. And this is basically what installs them for us, the package manager. We could go to the package manager console, type in a specific command. I can't think of any off the top of my head right now, and it would install packages we need or would need for us seamlessly. And unit testing and test automation. Unit testing is basically just testing each feature or each function along the way to prevent any mishaps in the future. You don't want to be coding lines and lines and lines on code, and then you just say, oh, let me test it now, and then you have an error, you're not really sure where the error is. So if we implement this function right here, we test it, make sure that it works, move on to another, test it, move on to another, test it. So that's basically how that research concept was incorporated in this application. As for test automation, we use a separate software to automate testing, Selenium. So lastly, the last research concept is continuous integration, and we achieve this by using GitHub. So we can see the commits for the project continuously integrating at each phase. So committing at each phase, so we can see, we can go back to a different version of the code if something's not working. And it's basically like I was describing in the source control management. So this GitHub is a source control management tool, and yeah, everything I said about the source control management would apply here. So that's basically it. Those were all the research concepts incorporated in this project. Thank you.